Moving into the final two lessons for Chapter 3, we're taking a break from systems of equations, but we're actually really just transforming them to what are known as matrices. In Lesson 3.5, we're going to look at performing basic matrix operations. A matrix is defined as a system of rows and columns. Unlike a system of equations where you have matching equations with matching variables, a matrix can have different types of rows and columns. So the dimensions of a matrix, we say the rows first and then by the columns second. The element in a matrix, or any element in a matrix, is a term that's within that matrix in a specific row and a specific column. Let's take a look at matrix A and matrix B. A matrix is defined or named by a capital letter. It says state the, that should be an I, state the dimensions of the matrix. We'll put a little I right there. Now if we do rows first in matrix A, there are two rows that go straight across, 1, 2. So we would say that this matrix has two rows. And then if we look at the column second, columns are always vertical. There are 1, 2, 3 columns, so this is a 2 by 3 matrix. In matrix B, thinking the same idea, again it's named by the capital letter. If we think the number of rows in matrix B, there are 1, 2, 3 rows. So we start off with a 3. But then as we look at the number of columns, there's only one kind of vertical connection with all three of those points. That makes this a 3 by 1 matrix. To determine an element, the numbers that are kind of the subset for the matrix tell you the row and the column. For that first element, it says determine A12. Technically, it's 1, 2. So this means if we go in row 1, column 2, here's how you would do that. Go back up to matrix A. Row 1 would be represented by the top row. So that's any possibility here. Column 2 is that middle column. Where those overlap would be the value for that element. So this is just going to be -4 in row 1, column 2. You try the next one, B31. See if you can determine the element that represents that location. If we look at 3, 1, it matches at 7. And the last one, A32, that would be row 3, column 2. Well, wait a minute. If that's row 3, we only have 2 rows for matrix A. We have row 1, row 2. There's no row 3. Therefore, this element does not exist. It's not possible. All right, let's move on to our next definition. Equal matrices have to have the same dimensions, so the same number of rows and columns. If the matrices are equal to each other, all you have to do to solve for a missing variable is set corresponding elements equal to each other and then solve. It says if C equals D, that means the elements in matrix C must be the same as the elements in matrix D. Solve for each variable. Well, if we kind of split this up into rows and columns, you can see that there are already some elements that match up. In row 1, column 1, we have 12 in matrix C and 12 in D. There's no variable there, so we don't have to do anything with that element. In row 1, the next column, column 2, we have 3x minus 12, or 3x plus 2 in matrix C and 23 in matrix D. What we can do with that is set those locations equal to each other. And that will allow us to solve for x. To get x by itself, if we move 2 to the other side, we get 3x is equal to 21. Divide both sides by 3, and x equals +7. Carry on to the next section. Down to the second row, we have 0 and negative 7y plus 3. Those elements should be equal to each other. Therefore, if we set 0 equal to negative 7y plus 3, we can work backwards to solve for y. Move 3 to the other side, and we get negative 3 is equal to negative 7y. And then to get y by itself, we'll divide by negative 7 on each side. The 7's cancel, the two negatives become positive. On the left, negative 3 over negative 7, the two negatives would also cancel, and we have y equals positive 3/7. And then last but not least, that matching corresponding element in row 2, column 2, both negative 14, no variable to solve. The last thing we'll do in the video today is add and subtract matrices. Again, we have to have the same dimensions in order to add and subtract. And the nice thing about adding and subtracting matrices is you just really combine corresponding elements to get a new solution matrix. In the examples at the right, it says given matrix M and N. Go ahead and change those. They should not be A and B. Given matrix M and N, perform each operation. Matrix M is a 2 by 2 matrix. There are 2 rows and 2 columns, so 4 elements total. So is matrix N. That's what allows us to add and subtract the corresponding elements. In our first example, M plus N, what I want to do is just take each element in M and add the corresponding location in N. In that first location, that's row 1, column 1, that would be negative 3 plus 6. In row 1, over to the right, that's column 2, 5 plus 5. Down to the second row, that's row 2, first column, 2 plus negative 8. And in that last element location, 0 plus 2. And all we need to do is simplify. In our final solution matrix, negative 3 plus 6 is positive 3. 5 plus 5 is 10. 2 plus negative 8 would be negative 6. And 0 plus 2 is 2. There's the sum for M plus N. If we reverse the order, notice what happens. To take N plus M, we would have 6 plus negative 3. Does that change our final answer? 6 plus negative 3 would be 3. Over on the right, 5 plus 5 would also give us 10. Down below, negative 8 plus 2 would be negative 6. And on the right-hand side, 2 plus 0 would stay 2. What's unique about adding is that it's commutative. We've talked about that term before. Commutative means you can add in either order and get the same result. Now subtraction, that's a different story. To subtract elements in a matrix, order does matter. So what we'll do is we'll take the matrix for M and we'll find each corresponding element using subtraction. Negative 3 minus 6. To the right, 5 minus 5. Down below, 2 minus negative 8. And last but not least, 0 minus 2. Let's finish the difference for this solution matrix. Negative 3 minus 6 would be negative 9. 5 minus 5 is 0. 2 plus negative 8 would be 2 minus negative 8 would change to plus. 2 plus 8 is 10. And our final element, 0 minus 2, is negative 2. There's the difference matrix for M minus N. And that will do it for the video for 3.5. I'll check these in class tomorrow, and then we'll finish the notes for 3.5 on the back.